Hi everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 3439 reschedule meetings for maximum free time 1. You can pause the screen and read the problem statement. I'll simply explain you what it is basically trying to say and what we have to achieve. So these are the examples that have been given to us and these are the constraints. Okay, let us try to focus on the screen and I'll tell you like what are the inputs and what we have to achieve from this one, and then we'll discuss about the logic. We have given a start time, end time array. There is an event time also, it has been given, and k value is also given. So there are multiple events that are occurring. Those events start from the 0 and they will go till this end time. Okay. So any two events that are happening, right? So those are basically non-overlapping events. These all the events that are occurring in this particular range. These all events are non-occurring. Non-overlapping events. Sorry, if I said non-occurring, non-overlapping events. These all the events are non-overlapping events, and they are happening between 0 to 15. Whatever the event time has been given to us, maximum any event that basically happens, that happens between 14 to 15. Okay, beyond that we are not going to get any, we will not see that event basically in our array. Okay, you know, we have to modify these events. Okay, we have to reschedule this events timing. Okay, whatever the events timing that has been given, the first event basically starting from 1. Okay, it is happening between 1 and its end time is basically 2. So this is the first event that has been there. Second event is like 3 to 4. In between this time the second event is happening. Next is like between 5 to 6 and 9 to 10 and 13 to 14. These are the events that are basically happening in this given time. So we have to get an answer. Okay, maximum answer. The maximum answer should be between any two events. Okay, between any two events, whatever the gap that we are getting it, whatever the gaps that we are getting it between any two events, so that gap should be maximum, and that is something what we have to return, and that we can achieve it by simply rescheduling these events. Okay, and the way we can reschedule these events is like, let us suppose if I try to reschedule this 5 to 6 event, is whatever the event that is happening between 5 to 6, if I try to reschedule, I can have boundary that this event can be shifted from 4. At max I have range in the left side is 4. Beyond this I cannot go further, because I cannot simply overlap this event on this particular event. Okay, this particular 5 to 6 event I cannot simply overlap, or even I cannot change this to other order. I mean like, let us try to pick this event and let us try to place right over here, and from 0 to 1, these options are not valid one. Okay, so I can either shift in the left side whatever the previous event that was there till that point, and in the right side also whatever the next event that we have, or the extreme right side's boundary, till there we can take it. Okay, because this was the last event, so I can shift it till this last event time that we have given to us. Okay, so this way we can shift these events. Okay, so yes, any event that we have, either we can shift it to the extreme left or extreme right. Extreme left in the means whatever the previous in events last time that we have, from there we can start this event start time, new event that whatever we are trying to shift. Or if we try to shift it into the right side, whatever the next event that has been there, we can go till its start time. Okay, so whatever this event that we are trying to shift, we can place it between 8 to 9, or this previous index was like between 3 to 4, this event was there, right? So from 4 to 5 we can place it. Okay, this way we can modify or reschedule its timing. Okay, that is the idea. Now by rescheduling this, whatever the gap that we are getting it between the events, that is something what we have to get it, and it should be maximum. So we have multiple possibilities. Okay, so now we have this given k value as well. So at max k events we can reschedule. So two events we can modify by simply modifying them, whatever the gap that we are getting it between the events, the maximum value that we get it at any point in time, that is something what we have to print it into the output. That is the simple question that we have given. Okay, now since k value is basically 2, if we try to reschedule any events, right, randomly, let us suppose first event I tried rescheduling it, this particular event can be placed, this particular first event can be placed at 0 1 or at 2 3. Okay, these are the places that we can shift it. We can place these events at any point in time between this 0 to 3, because that is the range that it has. But by placing it at extreme left or extreme right, we can get the best answer, right? That way we can achieve the gap, best gap that we can get it from there. Okay, so if I modified the first event, okay, if I modified this first event, And now try modifying the second event from that is happening between 9 to 10. Are we going to achieve best answer? No, right? Because this basically implies gap between these 0 to 3. And this particular event will get shifted either at 6 to 7 index or either at 12 to 13 index. Okay. So here gap and this particular whatever the gap that we are getting it, are they going to give us the best answers? No, right? So any two adjacent events, because k value is basically 2, any k adjacent events, if we try to shift their positions, that way only we can achieve the maximum gap. Okay, what I'm trying to say is, now let us say that I can achieve the adjacent key events that we have, right? So the first event, let us suppose we try to place it at 0 to 1. Second event, since k value is basically 2, now I can shift two events, like from first to 2. Second event we placed, whatever this first event we got placed right over here. Second event we rescheduled from 1 to 2. Two events got rescheduled. Now the next event is directly between 5 to 6. Okay, so this gap is basically 5 minus 2 is basically 3. This way we achieve 3 units gap by simply rescheduling the adjacent events. Okay, the idea is pretty much clear. So yes, any adjacent k events, if we try to reschedule, that way only we can achieve the best answer from this one. Okay, now let us try to reschedule this different combinations we have, right? So if we try to reschedule these two events, we are getting the answer like from 2 to 5, we are getting a gap, right? From 2, because next event is basically occurring between 5 to 6. So this is the gap that we can achieve it by simply rescheduling first and second event that we have. Okay, next is like we can simply consider that this particular whatever the 1 and 2 this particular event that has been there, we will not reschedule this. What we will try to do is we can reschedule this 3 to 4 and 5 to 6, because there is a chance that if we directly looking at this image, we are getting that from 6 to 14, whatever the events that we are having, if we try to reschedule, we are obviously going to get the best answer. Like this, if we try to place right over here, and this if we try to place right over here or here at any point in time, this is the gap that we are getting it, like from 8 to 15, that is the gap that we are getting. And by simply modifying these two events, right, we are getting best answer. So yes, why not to try all the different possibilities? So it is like we are simply sliding these windows, right? So we can use sliding window technique, like from first these two events we tried modifying by simply placing from 0 1 and 2 at these places. We got the answer like from here, from 2 to 5, that is the answer that we got. Okay, now we will try to do is like we will try to shift these two events. Okay, now this event is not basically got shifted, so the third index, the event that is happening, this event can be placed right over here. Okay, right over here we can place it, because this is event is not getting modified now. Okay, and this 5 to 6 can be placed right over here. So in between like 2 to 3 and 4, we place these two events. Okay, we place these two events. Okay, these events are not getting overlapped. Okay, that is something what we have to understand it. So now this way also we can try to do it. Now the moment we place these events, like from next event is basically occurring at 9 to 10. So this gap between this 4 to 9 is basically 5, because 9 minus 4, if we do 5 is the answer that we get it. So 5 is the gap that we are getting it by simply modifying these two events. From previous one, when we modified first and second index, we got answer as maximum answer as 3. Okay, because 5 minus 2, when we do 3 is the answer that we were getting it. Now when we tried modifying these two events, I can either shift it in the left side or shift it in the right side. Okay, in that way both the ways answer is going to be same. Okay, what I'm trying to say is like, let us suppose instead of placing these events, now let me just clean this up. Instead of placing this way, we got answer when we shifted it at 2 to 4 in between these locations, whatever these events that we have. When we tried shifting at these locations, the gap was like from 4 to 9, we got the answer. Next thing that we can do is like we can shift this event right over here and this event right over here. So it is like again from 8 to 9, the third event is something what we placed, and from 3 to 4, the another event is sorry, 3 to 4, I'm saying 7 to 8, the another event, this particular q, let us suppose this is the q2, q1, q3, q4 and q5. When I place q2 at 7 to 8 and q3 at 8 to 9, because from 9 we are getting another event. Okay, so it is lagging a bit. This way also we are going to get the same answer, because from the adjacent event that we have here is like between 1 to 2, q1. Gap between this is like 2 minus 7 minus 2 is again 5. 5 is the answer that we are getting it. And in the previous way also, from 2 to 4 we place these events, and there also we are getting the answer as 5, because gap between 9 to 4 is basically 5. So in either way, if we try to place these events, we are getting the answer, so we don't have to worry about that, like where we have to place them. Okay, the idea is pretty much clear now. Okay, now let me just take a quick pause because it is lagging a bit. I cannot explain it further. I'll be back. Okay. So now we tried shifting this Q2 and Q3, these two events, and we got the answer as 5. Okay. Next is like we will try to shift this Q3 and Q4. Okay. Now we are not shifting this Q2 anymore. So the left boundary for this Q3 is basically, we can place it at 4 to 5. Okay. When we place this Q3 as 4 to 5, okay, what we can do is like this Q4 also we can place it from 5 to 6, because this difference is basically 1. So yes, it is occupying 1 unit of time. Okay. Now the next, since we modified this Q3 and Q4's position, okay, the next event basically happening at 13. Okay, so here this is happening. So between this, the gap is like 13 minus 6 is basically 7. So this way we are getting it 7 as an answer by simply modifying Q3 and Q4's position. These two events, when we try to reschedule, the rescheduling is happening only extremely at this place, or from here. Okay, either side we can place these events, both events, and that way the answer that we are getting is like 7. Okay, so yes, now the idea is pretty much clear. We will keep on moving with k events that we have. Okay, whatever the k events that we have, and we will keep on try to reschedule their positions. Reschedule means like we will simply get the gap between this left and get the gap between the right. Okay, whatever the gap that we are getting it, and we can simply add them. Okay, whatever the gaps between these events that we have. See why? Because see, what I'm trying to say is like, when I tried modifying this Q3 and Q4 position. Okay, so Q3 and Q4, if we try to modify the Q3 and Q4's range is basically from 4 to 13. Okay, from 4 to 13 we can place this Q3 and Q4 anywhere. Okay, now Q3 is basically occupying 1 unit, Q4 is basically occupying 2 units of time. So this gap between this 14 and 13 and 4 is like basically 11. Sorry, it's 9. Sorry, it's 9 basically. We get the 9 as answer. 13 minus 4 if we do, and these 2 units basically again got occupied, so answer is basically 7. So 7 is the answer that we are getting it, and that we can easily achieve it by simply considering their gaps. So gaps between 4 to 5 is 1 unit. Gap between this 6 to 9 is again like between the events, whatever the gap that we have, that is the answer that we are going to get it, right, by simply resolving them, either putting into the extreme left or putting into the extreme right. Whatever the gaps that we have in between these events, that is the ultimate answer, right? So here it is 1, here it is 3, here it is 3. So in total the answer is basically 7. So yes, I can either place it extremely left or extremely right. These two Q3 and Q4 are going to occupy 2 units of place only. Okay, wherever we can place them, and whatever the remaining gap that we have in between these two, that is the answer that we can get it, right? So yes, the idea is pretty much clear now. So we will use sliding window technique by simply whatever the gaps. Let us suppose first these two elements is something what we have tried going. Okay, we tried by shifting their positions. This first two, we are not sure, right, between which events when we try to modify, we are getting the best answer, right? So first thing that we will do is we will consider their gaps. So whatever the gaps that we have, so here it is 1 unit of gap. Here it is 2 unit of gap. Here it is 1 unit of gap. Okay, these gaps are something what we have to consider in another array, because we cannot keep on calculating their differences. What is the gap between these this? It is best that simply by calculating their gaps earlier, by simply going from 0 to 1, what is the gap? If it is this first event starting at 0th index, the gap is basically 0, so we don't have to worry about it. But now since it is started at first index, the gap is basically 1. Between Q1 and Q2, the gap is basically it is 1 unit of gap. Sorry, it is not 2 unit of gap, it is 1 unit of gap between this Q1 and Q2 event. Again Q2 and Q3, the gap is basically 1 unit. Between these events, the gap is basically from 6 to 9, it is 3 unit of gap that is there between these two events. Between these two events, the gap is basically again 3 unit, and from last event it is 1 unit of gap that is there. Okay, so yes, we got these gaps by pre-computing them. Now the idea is pretty much clear. We will try to use the sliding window. We'll keep on covering the k index, k events. Okay, First, we will try to cover these two events. K events. What are the two events that are happening? K is basically two. So two events is something what we will cover, and we will simply calculate their gaps. Okay. How we will calculate when we are covering this Q1, Q2? We have to make sure that this zeroth index gap is something what we have to consider. This gap and this gap. Okay. These three gaps is something what we have to cover. So when K is basically equals to 2, we are basically covering three gaps, right? Because the first index, when we try to modify, it will either go extremely at any point in time to the left, and whatever the right side gap that is there, that is also we have to consider. So these two gaps for a particular first index is basically at every point in time it is going to be there. Okay. So yes, when K value is basically 2, we will, from this gap array, we will cover three, whatever the gaps that we have, those values is something what we will cover. So from gap between Q and Q2, when we reschedule, the answer is something what we are getting is basically 3, simply covering them. Now next is like, we will not modify the Q1. So what we have to do, the sliding, in the sliding window, now the index starts from here to here. Okay. First we computed this answer. Okay. Next we have to compute this answer from 1 to 3. Next we have to compute the answer from this one. Okay. It is like simply a sliding window, right? Technique, whatever the technique that I am applying right over here, it is basically the same. So now let me try to change the color. This is another answer that we can get it from 113. Next is like from 113 we can get it, this one, and the last answer is like from this one. Okay. So this way, like whatever the gaps that we are getting it in between these events, if K value is basically equals to 3, the window size will basically whatever this gap array that we have created, that's window size is basically going to be K plus 1. So 4 units is something what we have to consider, and whatever the previous index value that we have covered it, that is something what we can discard easily by simply, if we are window size is getting shifted from this one. So Q1's, this gap is something what we can discard it. So for the next, for this Q2 and Q3, the gap is from here to here. So this gap and this gap, these three values is something what we have to consider. So gap between 2 to 3, gap between 4 to 5, and gap between 6 to 9. Okay, it is not getting updated at all, but yes, gap between 2 to 3, gap between 4 to 5, and gap between 6 to 9. These three gaps, if we simply add them, so we will get the range for this Q2 and Q3, whatever the answer that we can get it, maximum gap, that is something what we will achieve it. For gap between Q3 and Q4, we can simply remove this Q2's gap between 2 to 3, whatever the gap that we have. Okay. By simply removing it and adding this new gap for Q3 and Q4, the answer is something what we will achieve. For Q3 and Q4, the answer that is something what we can easily achieve. Okay. The gap between 4 to 5, gap between 6 to 9, and gap between 10 to 13, we simply add them. We are going to get the answer. Okay. So simple sliding window technique is something what we will achieve. We will apply right over here. And previous index is something what, if the range, whatever the K range that is being given, if it is new index is something what we are trying to add, we will discard whatever the previous value that we have added into the answer. Okay. So yes, so let me try to write the code, since it is lagging a lot, so I'm not going to cover another example, but yes, I think it should be clear for now. So let us try to create, first is like let us try to get length of this all the events. I'll cover it in this one. Now the length is something what we achieve. What we will try to do is we'll create a gap array. Okay. In the gap array, we will store all the gaps between the artisan events. So it is like from starting from 0th index, we are covering it, right? So yes, it should be like n plus 1. Okay. Because there could be a chance that the first event could start from the 0th index. Okay. Or even it could start from the any other index as well. So yes, the gap array of this, whatever the gap array at 0, this value is basically whatever the start time that we have, start time of the first index, start time of the first index minus 0, or it is like whatever the value has been there, that is the gap array of 0, we will place it. Okay. It could be 0 or anything. Okay. That is something what we place it. Now from the first index onwards, for this gap array, okay, what we will do, the gap array of 1 or this I, it should be starting from the first index. Okay. Because 0th index we are already filled the start index value. It is like for next index end time, whatever the next index start time, whatever the start time that we have, start time of this I minus previous index end time, so I minus 1. This, whatever the difference that we do, that is the gap we can easily achieve. So between Q1 and Q2 events, the end time, whatever the Q1's end time, and this current start time, if you directly subtract, we will get a gap arrays value. And at last, whatever the last index that we have, Okay, gap array of n, and that position, and there could be a chance that this last event that has been there, it is not accurately at the event time, whatever the event time that has been given. So yes, that is also we have to cover right over here. So event time minus the end time of last index. Okay, n minus 1. Okay, whatever the end time of this last event that we have, that is something what we can get it. So now the gap array has been created. Simply we have to use the sliding window technique. Now let us create here another window size. Window size is basically equals to k plus 1. That is something I already explained you why we are covering k plus 1 size. And we will simply run a for loop initially for I equals to 0, I less than this window size, whatever the window size, and I plus plus. This way, like if k value is basically 2, two gap arrays values are something what we have to consider. Okay, let me create here a current sum. Okay, in the current sum, I'll simply add these values. So in the current sum plus equals whatever the gap array of I. These values are something what I have to add here. Why I have written grab. Okay, gap array is something what we are keep on adding it now for starting from 0 till let us suppose if k value is 2, two events when we try to modify the three gap arrays values is something what we have to cover. That is something what we have done right over here. Okay, now once we have covered it all these value, there could be chance that for the going ahead by discarding the first event, if we try to modify next two events, we can get the best answer. So yes, that is something what we have to again try to see. So this I basically start from the window size now. I should be less than the n, I plus plus. We'll keep on going. And what we'll do is here, let us try to create here an answer, another answer variable, and this is currently pointing to this current sum. Okay, whatever the current sum has been there, that is something what the answer is currently pointing, and this answer is something what we will return ultimately. Now in the current sum, what we have to do, current sum, here we will add whatever the new incoming gap that we have for the next event. Okay, gap array of I, and we have to discard the previous last index that we have covered it. Okay, so from the gap array, okay, from the gap array, whatever the last index that we have, I minus window size. Okay, here it should be window size is something what we have to cover. Okay, so yes, I think it should be clear, right? So whatever the last event that we have considered, that is something what we have to remove it from here. Okay, now we will simply check that if this current answer is maximum, then simply update it into the answer. Okay, math.max current sum, and here the answer. Okay, I guess this should be clear. So we are just simply using the sliding window and basically covering the gaps, whatever the gaps between these two windows, whatever the k window size events that we have between them, whatever the gaps that we are getting in, that is something what we are covering and keep on adding them. Let me try to run the code and see if it is having any issues or not. Okay, all test cases are getting passed, and if we try to submit, it should work fine. So if we discuss about the complexity here, this particular for loop is basically taking. Okay, it is a wrong answer. Let me see what, why, and where it is getting wrong. Input basically 19, k value is basically 1. Okay, so expected answer is 21. So we are getting some wrong answers. Let's see what and where we went wrong. Start time is something what we have added at gap of 0. Gap of I is basically equal to start of I minus end time of I minus 1. Whatever the previous index that we have, that is fine. Gap array of n equals to event time minus end time of n minus 1. This is also fine. Okay, now window size is basically equals to k plus 1. We are starting from 0. We are not going to go till k plus 1. I mean from 0 we are starting it, right? So obviously we will cover all the three if k value is basically equals to 2. So we are covering and we are getting the sum. In the answer sum we have added it. Whatever the gaps we have been there, we got there. We added all the gaps. Now starting from this one, okay, we have to go till the last index, right? Because obviously there is a last event also. So yes, I think this should be clear, right? So because we have in the gap array we have the last whatever the last in the event that we have, it could be again that whatever the gap between this last and the event time, that is also we have to consider. That was something it got missed. I guess that was the error. I'm not sure if we are having any other issues. Let me just copy this test case and let me see if it is working fine or not. So if we discuss about this space and time complexity, it is like big O of n in both the times. We are using sliding. So yes, we are keep on moving in a window size, and yes, that way it is like big O of n only. First, we just calculated a k window size sum, and we are simply discarding the previous sum and simply adding a new sum into that one. So that is all about this particular question. Okay. Yes, if you get the idea, thank you for watching this video. Bye bye.